S2. This is the complete unit, going through the review for all of it. We'll be working through our review question by question here. Feel free to stop this video, to start it over, to do what you need to really understand what's going on here. So really make sure you take your time. We're going to start off by completing the square. If you remember on completing the square, there's a couple of things that's important. First off, A, that first term, needs to always be positive 1. So if anything is there other than positive 1, we need to divide by it. That includes a negative, that includes a number, doesn't matter, we need to divide by that first. We also need to make sure everything's on one side here. So we've got y equals over, if you get over to our next one, we've got it equal to a number. So we'll actually need to take care of that before we move it. So the first thing we're going to do is we're going to divide by that 2 all the way across and put that out front. So we factored out a 2, so we've got n squared plus 6n plus 5. And we've got the equals y, but we don't need it until a little later. So let's move that to a new screen here. So we've got this and a little more room to work with it now. So the first thing we're going to do is we're going to write in our blanks like we're used to seeing. So we've got 2 parentheses n squared plus 6n blank plus 5 blank, close my parentheses. If you remember, in the parentheses is b over 2 squared. So we got 2 times n squared. B is 6. 6 divided by 2 is going to be 3. 3 squared is 9. So I'm going to add 9 in that first blank, plus 5. In the second blank, I'm going to subtract 9. Then we're going to combine those last 2, and we're going to factor those first 3. So we have 2. Now, when we factor, first off, we have a number out front, so we're going to have a double set of parentheses there. When we factor, it always follows that same pattern. The variable plus or minus b over 2. So 6, it's a positive 6, how we know whether it's plus or minus there. We got 6, so 6 divided by 2 is 3, so I got n plus 3 squared. Then we got 5 and negative 9, so it's going to give me negative 4 in parentheses. Now, when I factor out that 2, I know that I'm going to have to bring it back at the end. So what's going to happen is I'm going to distribute that 2 to both terms. So I've got 2 times n plus 3 squared. And I've got 2 times negative 4, which is going to give me negative 8. I say that equals y. Because that didn't disappear, we just ignored it till the end. And that is our equation in vertex form after we've completed the square. Alright, let's hit our next one. So on our next one here, as I said, we've got it equal to a number this time instead of equal to y. So we've actually got to make sure we move that 5 to the other side before we begin. So we're going to do that. We're going to subtract 5 from both sides. We have 5n squared plus 19n minus 68 equals 0 or y, because we're not actually using it to solve at the moment, so y is fine. So let's take a second and let's move that to another screen. Alright, now we've got plenty of room to work with that. So the first thing I said, you need to make sure that a equals positive 1. Our a equals positive 5, so we need to divide everything by 5. And the reason we're doing that is we're factoring that 5 out front. So now we have n squared plus 19 fifths n minus 68 fifths. And we're going to bring that y back later. You notice we've got some fractions here, and we've got some ones that are going to be kind of ugly before we're done. So let's make sure we're paying extra close attention and being careful with those fractions. So we're still going to set up 5 times n squared plus 19/5 n blank minus 68/5 blank, close my parentheses. Now if you remember in that blank, I get b over 2 squared. Now with a fraction, we're going to do that the same way we've done with the other ones. We're going to punch it in our calculator, and we're going to square it. Excuse me, we're going to divide by 2, and then we're going to square it. And it's going to give us another fraction out. We always want to keep those in fraction answers. So when we divide it by 2, we're going to get 19/10. And when we square that, we're going to get 361 over 100. So we're going to add 361 over 100. And we're going to subtract 361 over 100. Now we've got these kind of ugly fractions to deal with, but it's really not going to change anything long term how we solve this. We're still going to combine those last two. We're going to pay attention to that sign on both of them. And then we're going to factor those first three. When we factor, it always follows the same pattern. Variable plus or minus b over 2. Now we had to do b over 2 to square it for these blanks. If we paid attention, b over 2 was 19/10. So plus 19/10. Almost forgot my double set of parentheses there. Squared. Minus, and I'm going to do negative 68/5 minus 361 over 100. And when we subtract those, we get negative 1,721 over 100. Still in parentheses there. And the reason is because we factored out that 5. If you remember, we factor that out, it's got to follow us all the way down, and we're going to distribute that to both of those terms at the end. So we get 5n plus 19/10. Write that a little neater for us. Tenths squared minus 1,721 over 20. So when you multiply that out, that's going to affect that denominator. And we're going to have y equals, and that's going to be our final answer. That's what it looks like in vertex form. Alright, let's go to our next one. So our next one here, if you notice, we don't have a C term. I recommend putting a 0 in if you don't have a C term, because anytime you have that, what most people forget to do is add or subtract that last term, and it messes up the whole equation. So when you rewrite this, go 4v squared plus 16v plus 0. And it may seem like a simple thing, but it's a little thing that keeps you from making a big mistake. So let's take that over where we've got a little more room to work with it. So we've got our equation. First thing we do is make sure everything's on one side, and we've got a y over here, so it is. Then we need to check our a, and our a is positive 4 on this. And remember, if it's anything other than positive 1, we've got to divide. So we're going to divide everything by 4 because we're going to factor that 4 out front there. Parentheses is going to give me v squared plus, sorry, I didn't want to write there, 4v plus 0. We're going to remember our equals y in just a minute and bring it down. So we're going to go ahead and write that again with our blanks in it this time. So v squared plus 4v blank plus 0 blank. And if you forget that 0 in there, what happens is people forget this step right here, and it messes them up. That 0 right there can change signs for whatever that those two combined terms are. So make sure you pay attention, have that 0 there so you don't mess it up. So you're going to combine, we're going to do, before we combine, we're going to do b over 2 squared. So b is 4. 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 in the first one, I'm going to subtract 4 in the second one. I'm going to combine those last two terms. I'm going to factor those first three. So I've got 4, double set of parentheses, v, and remember that it's going to be variable plus or minus b over 2, so it's going to be 4 divided by 2, which is positive 2, squared. 0 minus 4 is negative 4, all in parentheses. Distribute that 4 out, so I've got 4 v plus 2 squared minus 16. Need my y equals out front, and that's my final answer in vertex form there. Remember, when completing the square, that's what we do, is we get vertex form. So let's do our next one. So if you've noticed, all of these have been just a little bit different. So is this one. So we're going to write that out. A squared minus 2a minus 48 equals y. And the reason this one is different, if you notice, a is 1 on this, so we're not going to have anything to divide by. That's the big thing that's different on this one. So let's take that one over where we have a little more room to work with it. Alright, so we do still check our two things first. We got everything on one side, and we've got a out front is positive 1. Now remember, we talk about a, it's that first coefficient, not the variable in this one. We're talking about out front there, it's positive 1. So we're going to start in by rewriting this with our blanks in. A squared minus 2a blank minus 48 blank. Those blanks, we put b over 2 squared. b is negative 2. Negative 2 divided by negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So I add 1, I subtract 1. I'm going to combine those last two. I'm going to factor those first three. I get a, it's going to be plus or minus b over 2. So negative 2 divided by 2 is negative 1. So it's going to be minus 1 in this, squared. Negative 48 minus 1 gives me negative 49. I need my y equals out front. And that's my final answer on that. Alright, good. Let's move to our next one. Alright, so for this next one, they give us vertex form, and they want us to find the vertex, and they want us to describe the transformation. Now, for some of you, this doesn't look like vertex form because I don't have the parentheses there. And the reason we don't have the parentheses is because that interior number is 0. So if I add or subtract 0, it doesn't change anything on that. So I've just got the x squared left over. So I can still use that to find vertex form. But I'm also going to remind you how to do it on the calculator as well. So if we're doing this from vertex form, if you remember, your vertex from vertex form is hk. But in the original equation, h is negative, and here h is positive. So what happens is we have to change the sign of h when we put it in vertex form. So on this one, if I look, h is always inside the parentheses, and there are no parentheses. That means h is 0. And that's actually the easiest one. If you've got no parentheses, that means h is 0. If you have no number outside the parentheses, we're going to get to one of those here in a little bit. But this number out here, if it's missing, you just have the x plus or minus a number squared in parentheses with no plus or minus number after it, then k is 0. So on this one, if we look outside the parentheses, or the ones that are missing here, that extra number, that's k. K we use just like it is. We don't change the sign. So it's negative 4. For transformations, we check a couple of things. We check a first. Our a value on this is positive 1. So that means we have no stretches, we have no shrinks, and we have no flips. That's good. That's one less thing we got to worry about. Now we just got to worry about left, right, up, and down. So if you remember your x values left and right, or we can remember our h values left and right, if we look at our vertex, 0, we didn't move left and right at all. So all we got to worry about on this one is k, which is up and down. K is negative, so that means we moved down 4. Looks a little different, but still pretty straightforward and still what you're used to. So let's look at our next one. So, using your vertex form, I got HK. H is inside the parentheses. I do have the parentheses this time. You got to remember that H we change the sign of. So instead of -3, we're going to have +3. We got K outside the parentheses. We don't change the sign of it. So it's +15. All right. So now we've got to look at a couple of things. We start off looking at A. A is -1. So it being 1, whether it's 1 or -1, we don't have a stretch or shrink, but because it's negative, we do have a flip. So we've got flipped. Got to worry about left and right. So if we look at the vertex, it's easier for a lot of people because we've already changed the sign. We don't change it again. So it moved right 3. And we look at 15, which is positive, so we went up 15. Right? Now, reminder of these things, the only one that's going to be difficult, and since you don't have to tell the equation from it, you can still do this. You can look at your calculator and see all of these things. If you type in this equation up here, just like it's written, you can look at it on your calculator and look, oh, it's been flipped upside down. Oh, the vertex has been moved to the right 3. It's been moved up 15. The last one we did, you could see that it was just moved down 4 and wasn't stretched or shrunk or flipped or anything. Type those in on your calculator if you get stuck on figuring out the transformations, because most of you can tell that from a graph, and you only have trouble trying to tell it from vertex form. So if you get stuck with that, punch vertex form into y equals. That's all you got to do is go to your calculator, y equals, and type it in just like this right here. You don't have to change anything. Your calculator will do all the multiplying for you and put it in standard form and graph it. It's real nice that way. All right, so let's go to our next one. So again, we look at H and K for our vertex. Remember, H is inside the parentheses, K is outside. We have both of them this time. And I've seen a small typo here. That should actually be a squared, otherwise that doesn't work. All right. So, we've got our vertex here. We look at H. We got to change the sign of H, so instead of +1, we have -1. We look at K. We keep the sign of it just like it is, so we have -7. Transformations, we have to look at several things. One is we have to look at A. That's what I recommend looking at first. So you see we have -3 for A. So negative tells me it's flipped. The 3 tells me a stretch. You remember, stretch makes it get taller faster and faster, so it's tall and skinny, like our silly putty. Remember I told you to think that parabolas are made of silly putty. If you pull on it, you stretch, you make it taller faster, it gets skinnier. So the first thing we're going to do is we're going to say it's flipped, stretched. Then we got to look at left, right, up, and down. If we look at our vertex, it tends to be easier for people. So I'll look at -1, that's left 1. And I look at my K, my second value here, it moved down 7. Now the flipped and stretched, it doesn't matter what order they are. Generally we do left and right before we do up and down. Same reason we do X before Y. We do left and right before we do up and down. Flipped and stretched don't really matter. Again, if you got stuck on that, you need to punch that in the calculator. Now, if you want to punch that in the calculator without the squared on it, that's going to mess stuff up. You're just going to get a straight line. But now that you've watched the video, you know there's a squared there. Alright, so let's look at our next one here. If we look at our next one, we notice it's different. We have H, but we don't have K. So some of you would see that and say, oh, that's not vertex form, but it is. It's still there. So I'm going to take my vertex, and I look at H, which is positive 15, but I change the sign to pull it out here for my vertex, so I have negative 15. Then I'll look at K, and K is missing. Now that means you can't say I don't have a K. If there's not a K written, K is 0. So transformations, I'll look out front at A. A is positive 1. There's nothing written there, so that means it's positive 1. That means I have no flips, I have no stretches, I have no shrinks. I look at my vertex, I can tell that I move left 15. I look at 0, it tells me I didn't move up and down at all, so I don't need to write anything. So when I do this, something that gets people messed up is they want to, you need to either use the vertex form or the vertex. Don't try to use both for your transformations. That's one thing that messes people up. If I'm going to use the vertex form, remember I've got to flip that, and so positive 15 actually tells me I move left 15. If I use the vertex, I don't flip it again. That's what a lot of people want to do. Say, well, I flipped that. That's only if you're using vertex form. What you use here, if you're going to use the vertex, is you use the actual vertex. Where did it move from 0, 0? Well, this one moved left 15 from 0, 0. All right? Again, if you get stuck, go to y equals, graph that, and you can see what it looks like. So let me get set up here for our next batch of problems. So this next section, it tells me to solve by any method, justify your solution, exact answers are best, but round to the hundredths place if necessary. The reason that's in there is because you have 3 methods that you can solve by here. I'm going to write them down at the bottom, even though it doesn't go with quadratic formula there. I'm going to write that down here just so we have that. So you've got the calculator. I can solve it by graphing. That's the actual method of solution there. You graph it, go to y equals, graph it, go to second trace, find my zeros, left bound, right bound. I'll go through at least one of those on the justify or the solve and justify through a calculator. Another option is factor and solve. I use my star method to factor it, and then I set my factors with a variable in it equal to 0, and that gives me my solutions. My third option is quadratic formula. Quadratic formula. If it tells me to solve by any method, I can use any of those 3. Now, the one exception being the factor and solve. And I'm going to put a little mark beside it. The reason that doesn't necessarily always work is because factor and solve only works if the equation is factorable. If it's not factorable, obviously that's not going to work. The other thing is calculator or the graphing method, because if it doesn't have real solutions, that's not going to work either. If you graph it and it doesn't cross the x-axis, the only one you can use is quadratic formula. Now, it tells me to use any method I want, but that doesn't mean all of them work. You've got to pay attention. When you go to factor, if your factoring doesn't work, you may want to check your calculator or try the quadratic formula. If you go to graph and it never crosses the x-axis, that means you don't have any real solutions. You don't need to bother factoring. You just need to jump to the quadratic formula. All right? Those are important things to remember. So let's go up here and try some of these. So let's try this first one. Now, k squared plus 8k plus 12. If you would like to use quadratic formula on all of these, that's fine, but do remember you got to show your work on there, and I can't just have magic answers. I've got to have something between setup and solution there. Having something so I can see where your numbers came from would be is required. It's not just appreciated, it's required. No magic answers. We don't want to become math magicians. So, I'm going to do this first one, factor and solve, just because it works. Or maybe it works. We'll see. May have spoiled the surprise. We'll see. So, A times C in this top one. So 1 times 12. So it gives me 12. A goes on top on those. B goes on the bottom. So I'm finding my factors of 12. So 12, I've got 1 times 12, 2 times 6, 3 times 4. I'm looking for a factor pair that adds or subtracts to get me 8. So in this case, 2 and 6. So I'm going to put 2 in one and 6 in the other, and it doesn't matter which one goes where. I need to check my sideboards there to see if they simplify. Neither of those do. So when I set this up, my factors are x plus 2 and x plus 6. That is factored, but if you remember out here, I said factor and solve. That is not solved yet. So what I have to do is I have to set both of those factors equal to 0. X plus 2 equals 0. So I'm going to subtract 2 from both sides, and x equals negative 2. Also have x plus 6 equals 0. Subtract 6 from both sides. So I get x equals negative 6. Those are my two solutions. Alright? If I wanted to use by graphing, I could have on this one. Would even give me nice pretty numbers. I can go to y equals, type in my equation, graph it, second trace, left bound, right bound, and get my zeros. I had to do that twice. If I wanted to use quadratic formula, remember quadratic formula always works. But I can use any method I want to here, so that's the reason I'm doing that. Alright, let's move some of this stuff out of our way so I've got room for other ones. Hopefully, if you haven't already, you've copied those 3 methods down somewhere so you can study that tonight if you don't have those in your brain. Those are the 3 methods of solving. That's what those are, the 3 methods of solving we've gone over. Calculator, graphing, factor and solve, quadratic formula. Those are the 3 methods. Now, on this one, I factored and solved. It says, justify your solution. What that means is, what did you do? So I need to label this. I'm going to put it in a different color so it's obvious that I labeled this. Let's do blue. Factor and solve. And that is enough for me that when you go to do this, especially if your work isn't 100% easy to find, as part of your answer, you need to have what you did. So you need, bare minimum on this test, you need x equals negative 2, x equals negative 6, factor and solve. Now if you do that, somewhere on your paper I'm going to need a star method and your solutions out there so that I can see that. But on the actual test, bare minimum needs to be those 2 things right there. Okay? So keep that in mind. Alright, for this next one, I'm going to see if graphing works. just because I want to mix it up. You don't have to mix these up. If if your solution methods will work for all of them, you can use the one for all of them. But I'm just trying to go through all of them here so you can see what you have. And so graphing is the next one I'm using. My calculator, graphing. Always pay attention because you need to have everything on one side. That's for all of these, and this one I do, because I've got everything on one side, but especially when you go to punch that in the calculator, if you don't have equals 0 or equals y over here, you're going to mess everything up. So what I'm going to do is I'm going to jump over to my calculator and type in that equation. So I've got that typed in. 3x squared minus 12x minus 63. I'm going to graph that, and that's what it looks like. Now it looks like I have nice even roots here, nice pretty numbers, which means I could have factored it, provided those are actually nice pretty numbers like they appear to be. I could have factored it, but I don't have to. So what I'm going to do is I'm going to go to second trace, my calculate menu, because anytime I do math on a graph, I go to my calculate menu, and I'm looking for a 0. Those what solutions are. Remember, solutions, zeros, x-intercepts, roots, all the same thing. So option 2, left bound. It doesn't matter which solution I find first, but I have to find them one at a time. Doesn't matter which one first, but I have to find them one at a time. So I'm going to use this one first. One other small thing before I do that, it's important, is that if you're going to use the calculator method, you have to be able to see both of them to find both of them. So that's another thing you need to check, is I can see where it crosses the x-axis 2 times, so I've got it. The other difficulty, if you're doing your calculator or your graphing, I'm just going to sketch this on here real quick, is if you have one that bounces off the x-axis. This can be a challenge here because what you actually have to do is remember to find your vertex instead of your left bound, right bound, because you only have one solution. So just another challenge of the calculator there. So left bound, I'm going to find this left 0 first. Don't have to, but I'm going to. If I look here, I can't see my spider. I'm currently at 0, negative 63, which is my y-intercept. I'm way off screen down there somewhere. So I'm going to hit the left arrow until the spider climbs up into my positive values. Itsy bitsy spider climbs the parabola. There we go. So I'm to the left of my zeros. I've got positive values now. I'm going to hit enter. Right bound, I need to be to the right of that 0, and if I look where the graph is to the right of it, it's below the x-axis. So hit my right button until I move below the x-axis, hit enter. Enter again for guess, because it's a stupid function. And I see my 0 is negative 3. So one of my solutions is x equals negative 3. Now I've got to go to the other one. Remember, I got to do them separately. So to do my other one, I'm going to hit second trace, which is my calculate menu. So anytime I do math on a graph, I go to my calculate menu. Hit option 2, because that's my 0. Now I need left bound. I need left bound for this point, and if I look for where the graph is to the left on this point, it's below the graph, below the x-axis there. But I need to be on the same side of the vertex as that. So what I actually still need to do is move my spider way over here. So I'm going to move that. It's going to have a nice little travel here. Hit my right arrow until my spider gets to the other side. Itsy bitsy spider climbs the parabola. Do 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 do. Told you, nice long climb here. There we go. The reason I didn't pause that and skip over that is because I know some of you have to hit a bunch of times and you think you've done something wrong, and I want you to see I hit it a bunch of times and it takes a little bit to get over there. So left bound, below the x-axis, we hit enter. Right bound, I'm looking to the right of that point. If I'm looking to the right of that point, the graph is above that x-axis. So I'm going to hit right until I'm above the x-axis. I hit enter. Now, my spider's in the way, so it's a little hard to tell, but if I look right here, these two arrows, if your calculator has those, all the newer models do. If you got those two arrows facing each other, you see they're pointing at each other. they're pointing at each other, that means you've got left and right correct. If they're pointing away from each other, you've got them backwards. Okay, that's one way you can check yourself. If you've got them backwards, it's going to tell you you did something wrong. So I hit enter, and it says my other 0 is 7. So they were nice pretty numbers, -3 and 7. Because these were nice pretty numbers, I could also use my table and find where y equals 0. It's also an option. So those are other things. If they're not nice pretty numbers, that option doesn't work. But if you go to your second table, and I'm looking for where y equals 0, see, one is at -3. And the other way, looking for y equals 0. And +7. Again, that only works for nice pretty numbers. If you've got a fraction or something along those lines, your calculator on the second trace will still find that. Will give you that decimal form of that fraction, but it won't appear on your table without adjusting a bunch of stuff. So I don't recommend relying on the table. If you see it like on that one, that it looks like it crosses at nice pretty numbers, you're welcome to check the table and save yourself some work. But don't do that unless it looks like nice pretty numbers. Otherwise, because it's pretty much just a waste of time otherwise. Let's head to our next one. So this one here, if you look, doesn't have a b value. Now that doesn't really change anything as far as how we solve it, but if we go to solve it, that, which method we choose can affect some things. For example, if we chose to use the factor and solve method, I would need to remember that on my star, if I'm using it, b is 0. I would also need to remember to check for things like a GCF, because a is not 1 here. A is +36. So I need to check for that. I need to check, make sure everything's solved on one side, regardless of the method. So I've got that. I'm going to use the quadratic formula on this one. I could easily factor and solve or use the calculator on this one, but I'm going to use the quadratic method just because. So I've got a equals 36, b equals 0, c equals -121. I'm going to plug that into my quadratic formula. So I've got the negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Make sure this fraction bar goes all the way across, because all of that is over 2a, not just part of it. I'm going to select this here and move it to another page so I've got more room to work. Gives me positive 17,424 all over 72. So I've got 0 plus or minus. I'm going to see if 17,424 square roots nicely. So I'm going to do the square root of 17,424. And I get 132 all over 72. So now I've got 0 plus 132 over 72, and I've got 0 minus 132 over 72. And see, that's where the sign is decided, is that plus or minus. So I've got 132 over 72. Let's move over here where I've got room. So I've got 132 over 72, and I've got negative 132 over 72, which gives me positive and negative. So x equals positive 11/6 and x equals negative 11/6. I have both of those answers. Notice the fraction is the same, but the answer is not the same. You can't just say, oh, it's 11/6 on there. I need both of those answers. I got a positive version and a negative version. That's an exact answer. Those are ideal. But if you don't have exact answers, if you use that as a decimal because you came up with the graphing set around to the hundredths place, so you'd have 1.83 when you go to graph that. So just keep that in mind. Let's go back to our next one. All right, for this last one here, I'm going to show you what happens with some of the other methods, but first you got to pay attention to one thing. If you notice, there is not a 0 here. They gave you 3 in a row that was a 0, and by they I mean me, and then gave you one where it wasn't all on the same side. You have to pay attention every single time to see whether it's all on the same side. If it's not, you have to move it. So I'm going to subtract 9 from both sides on this. So I'm going to wind up with, well, if it'll work with me here. So I'm going to wind up with 2x squared plus 6x minus 9. And I'm going to work on graphing that just to show you what happens and see if we can do that. And then if possible, I may try factoring that. Last, if I can't, I'm going to jump to my quadratic equation. Right, so I go to my calculator, I go to y equals, I type in my equation, and I hit graph. And this is what I get. All right. So I could certainly use that to get my answers. Now the tricky part on this one is that it certainly looks like we've got nice pretty answers. And if I want to, I can go ahead and check my table here. So 1, 2, 3, it looks like about -4 and +1. So I'm going to hit my second table, and maybe I'll get lucky and have really nice answers. So +1, no, that's -1. And I said about positive, yeah. Let's see. I have some negative. Nope, -4 is also -1. I don't know why I kept going there. You notice my table doesn't work, even though it looked like nice, pretty answers. And there's a lot of you out there, I'm sure you went, oh, 1, -4, that was my answer, and you got it wrong. That's why you don't look at the graph to find your answers. If you're going to do that, you hit second trace and you use the calculate menu. You're going to get a funky decimal on this one. Exact answers are preferred, so that means to get an exact answer, you're going to either need to factor and solve or use the quadratic formula. I will go ahead and tell you, if you go to try to factor this one, it's not possible. It's unfactorable. So quadratic method will work on this one, but if you want to use it to, I'm going to do one of your zeros here. I just did the quadratic formula, so you'd set it up the same way. I'm going to do one of these on the calculator so you know what it looks like if you get a funky decimal. So we're going to go to our calculate menu, that second trace. We're going to go to option 2 because we're looking for a 0. Left bound. I'm going to do the one on the right here since it's the one I'm closest to. So I'm going to just make sure I'm on the same side of the vertex. To the left of this one, there's my point, to the left of it, the graph is below the x-axis. So I hit enter there. Right bound, I'm going to be above the x-axis. I hit enter there. Guess, I hit enter because that's a dumb feature. And there's my really ugly decimal. So if I go to 2 decimal places there, that's going to be 1.098 decides there. 8 tells me that gets bigger, so 9 becomes 10. So I'd actually have 1.10 there. All right. Actually have, if I'm going to round, because it said to the hundredths place, I'd actually have x equals 1.10 as my solution there, rounded. All right. I would prefer, if you happen to see something like this, that you use the quadratic formula and give me the exact answer, because what's going to happen is you're either going to have a really funky fraction, or you're going to have a radical that simplifies. All right? Good. So let's keep this moving. So our next problem here, it's telling us to solve using the quadratic formula. We got to show our work to receive full credit and exact answers only. So that means we've got to make sure that we simplify radicals when possible. We don't use decimals. We don't use things other than exact answers. So we're going to start on this one. We're going to make sure everything's on the same side of the equal sign. It is on this one. An important first step. So what we're going to do here is we are going to pull out our A, B, and C. A, B, and C. I don't know why that is. So what we do is go ahead and pull out our ABC here, and I move to another screen here so that I've got plenty of room to work this out. C equals 9. I'm going to plug that in. Negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So when I do that, I get negative 1 plus or minus the square root of 1 minus 4 times 9, so negative 4 times 4 gives me negative 144. So I'm going to subtract 144 all over 8. When I simplify that again, I get negative 1 heading this way with my work. Negative 1 plus or minus the square root of negative 143 over 8. Now, I get to this point, I see that I have a negative under the radical. Anytime I have a negative under the radical, I've got to pull out an I. So I go over here and I pull my I out, plus minus I on the square root of 143 over 8. Anytime I get to this spot, I've got to check and see if there are any other perfect squares that will simplify into that radical. Before I do that, I check and make sure 143 is not a perfect square. It is not on this one. So when I do square root of 143, I get a weird decimal, so I'm going to start plugging in, checking my other perfect squares. That's 1, 4, 9, 16, 25, 36, 49, 64, 81. 4 looks a little funky. 4, 81, 100, 121, 144, 169, 196, and 225. So I check and see if any of those will divide evenly into 143. Generally, a good rule of thumb is to take 143 and divide by 2. Gives us 71.5. That's the biggest number that's going to go in there more than one time. So anything that's bigger than 71.5, I don't need to do anything with. So I check 64 and below. And if I'll start at 64 and work my way down, that will make it easier because I'll make sure I get the biggest one. And I check and I do 143 divided by 64, and I get a decimal, so I can't use it. 143 divided by 49, get a decimal. 143 divided by 36, I get a decimal. By 25, decimal, 16, 9, 4, all of those I get decimals. So that is in simplest form, but before I can write it as my answer, I need x equals. Because I didn't simplify my radical, there's not anything to check in this area here. Alright, so let's move to our next one. So I got 4 x squared plus 4x minus 8 equals 1. First step, I got to make sure it's all on the same side of the equal sign, and it's not on this one, so I got to subtract 1. So it gives me 4x squared plus 4x minus 9 equals 0. Now I can take and set up my A, B, and C and put up my quadratic formula. I can't do that until I have everything on the same side. It's important it's all on the same side. A equals 4, B equals 4, C equals negative 9. So I plug that in, negative B plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplify that some more. Negative of 4 is negative 4, plus or minus the square root. 4 squared is 16, minus 4 times 9. It's going to be, I got plus 144 on this because, like I'm subtracting a negative. All over 2 times 4 is 8. I'm going to shrink that just a little bit so I got some more room here. So now, simplify that again, going this way with my work. I got negative 4 plus or minus the square root of 160 all over 8. So I've got negative 4 plus or minus, before I do that, I was about to write the answer for you. When I get here, I need to check and see if square root of 160 is a perfect square, and it is not. It gives me a decimal when I square root that. So what I need to do is check that list of perfect squares. Let me go get it real quick. Alright, so now that I've got that, I'm going to see which of my perfect squares will divide evenly into 160. Again, a good rule of thumb is divide it in half, so divide by 2, I get 80. So anything bigger than 80 I don't even need to worry about. So if I take and draw a line anything smaller than 80, so I don't even need to try 81 because 81 is too big. If I start at 64 and work my way down, I'll have the biggest one possible. 64 decimal to 49, so I got 160 divided by 49 is a decimal. Divided by 36, divided by 25, 16 is going to give me my answer. So what I do is I have square root of 160 over here. Breaks into 16 times 10. And the reason I use those two is because 16 is in my list, and 10 is what I get when I divide 160 by 16. Now, because 16 is on my list, it's the one that I'm going to take the square root of. So 4. It's also the only one I can take an even square root of without getting a funky decimal. So what I'm going to get is 4 on the square root of 10. Alright. Now, what's going to happen is that's going to replace the square root of 160 when I write that. I'm going to select all of that and shrink it up a little bit so I got a little more room. And then I'm going to take and do negative 4 plus or minus 4 on the square root of 10, because that just replaced the square root of 160 over 8. And I'm almost done. What I need to do is check these three values. I call it the Bermuda Triangle because everybody gets lost there. So what we're going to do is we got to check those three numbers to see if they all divide by the same number. If there's a number they will divide by, I pick the biggest one possible that they'll all three divide by. If there's not a number that will divide evenly into all three of them, I leave them alone. This one, negative 4, positive 4, and 8 can all be divided by 4 evenly. So I'm going to do negative 4 divided by 4 gets me negative 1, plus or minus. 4 divided by 4 is 1, square root of 10, because I don't ever change my radical, it stays the same, all over 8 divided by 4, which is 2. Now I'm almost done here. I'm going to clean up this just a little bit. Because I'm multiplying by 1, I can actually delete that. I don't want to say it's completely gone because we don't want to be math magicians. We don't have things disappear. So we actually just multiplied by 1 there and it got the same answer. I also need an x equals in front of this before I can call that my answer, because anytime I have solutions, they're x equals a number. So when I'm done, that's going to be my final answer there. So let's move on to our next one. Alright, so we've got this one. First thing we've got to check is to see if everything's on the same side of the equation. And it is. It's all over there, so we're good. So we're going to take and pull out our a, b, and c. A equals 1, b equals negative 15, c equals 56. And I'm going to set up my equation. Negative of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I'm going to simplify that a little bit. Start with that. The negative of negative 15, I'm actually going to go this way with my work. Negative of negative 15 is positive 15 plus or minus the square root Negative 15 squared is positive 225. Minus 4 times 1 times 56 is 224. All over 2 times 1 is 2. I'm going to simplify that one more step. I got 15 plus or minus the square root of 1 over 2. Now, even though it doesn't look like it, if we go over here, our list of perfect squares, on that, leading that list of perfect squares is 1. So 1 is a perfect square, because 1 times 1 is 1. So what we're going to do is we're going to take the square root of 1, so 15 plus or minus 1 over 2. Now, because this one, we've completely gotten rid of the radical, we're going to take and pay attention to that plus minus there. What that does, that tells us to add those and subtract them. So we're going to split them over here. And we're going to go 15 plus 1 divided by 2. So always do the top first. 15 plus 1 gives me 16 over 2, which equals 8. Then I'm going to take and subtract them. So 15 minus 1 over 2. Always do the top first. So 15 minus 1 is 14. Getting ahead of myself. Over 2, which equals 7. So my answers on that are x equals 8 and 7. Ideally, we write those in order from least to greatest. It's not wrong if you do it the other way, but that's the way you're going to see it. Right? Good. Just remember there's lots of things you can mess up on, lots of little mistakes you can make. Be extra careful and try not to have any magic numbers. We don't want things disappearing. Being a mathematician is a bad thing when it comes to the quadratic formula. Okay? Let's move on to our next one. So the first thing it's wanting us to do is to actually complete this chart. And we've seen charts like this before, or you've probably seen them before. And it's just giving you one piece and wanting you to find a whole bunch of other stuff off that one piece. And it's because all of these things are connected that we're able to do that. So we're going to start off here finding that y-intercept. And the y-intercept is always just the c value of standard form. So we do that. We got to write it y equals 9. Or we can write it as an ordered pair if we want. We could do 0, 9. We don't have to do both. Either one is fine. Factored form, this is where we're going to take that star method. So if you don't remember the star method, let's come over here to another page and remind ourselves. So we've got y equals x squared plus 6x plus 9. The star, we have a times c in the top one, so that's going to be 1 times 9, which equals 9. A goes on each side, so that's 1 and 1, and then b goes on the bottom, so that's 6. Now what goes here are going to be factors of a times c that add to get me b. So what we do is we do 9, find factors. 1 times 9, 3 times 3. I've repeated a number here, so I'm done. So I'm looking for a pair of those that will add or subtract to get me 6. And I'm going to use 3 times 3. So I'm going to put 3 in one, 3 in the other. Obviously order doesn't matter on this one, but it doesn't matter ever. So I get x plus 3, because top number gives me number of x's. Bottom number is my constant. And I've got that twice on there, x plus 3. And one thing I didn't do, and I should have, is actually explain that you do need to check and see if these numbers will simplify like a fraction. 1/3 does not simplify. We've done this so much I about skipped over that step, but you need to make sure you don't skip over it. I saw that it didn't simplify, but I didn't say it out loud, so I'm saying it now to make sure you get it. Always check those sideboards to see if it simplifies. So the factored form on this is y equals x plus 3 times x plus 3. Some things you need to check before factoring. Always make sure that a equals a positive number. It doesn't have to equal 1, but it does need to equal a positive number. If it's negative, we have to factor out a negative first before we can get started. We also need to check for things like GCF. That's always a first on factoring. You got to be careful with those, because otherwise you'll mess up. I'm back to my chart. Y equals x plus 3 times x plus 3. Roots and intercepts, you're going to set both of those equal to 0. So that's x plus 3 equals 0. So it's going to be x equals negative 3 when I solve that. Subtract 3 from both sides. Now, if I do it for both of them, it's going to equal negative 3 twice. So that means I really only have one root or one solution there. I don't have to do it both times. Right? Vertex form. Now, depending on who showed you this, is whether you do this from the calculator or whether you do it from completing the square. You can always do it from either way. If you do it from standard form, you're going to punch it in the calculator. You're going to find your vertex, and you're going to put it in vertex form using your H and K. If you're going to complete the square, you're going to use your standard form for that. Now, I'm going to do it both ways. If I've got time here, at least I hope to. So I'm going to start off y equals x squared plus 6x plus 9. Complete the square. I've got x squared plus 6x blank plus 9 blank. What goes in those squares is b over 2 squared. That's what goes in those blanks. So b is 6. 6 divided by 2 is 3. 3 squared is 9. So I'm going to add 9. I'm going to subtract 9. And what I'm going to do when I put this in vertex form is going to be combine those last two and factor those first 3. Just like I did on that first page. So y equals, well, I don't need the y equals yet. So x plus or minus b over 2. So this one's going to be plus 6 over 2 is 3 squared. Positive 9 minus 9 gives me 0. So I actually just have y equals x plus 3. And that's because I only have one solution there. That means it's bouncing off the x-axis for me. So that's vertex form. Vertex, max or min. So first off, for max or min, I look at A. That's the number in front of the parentheses. This one, the number is positive 1. Positive 1 means I have no stretches, no shrinks, no flips. So I have a minimum, because it opens cup up. It opens up for me to, so that means I have a minimum. I look at my H value, positive 3. Remember, H, I have to change the sign to get my vertex, so it's going to be negative 3, comma, K is missing. That means K is 0. I could also go to my calculator, look at second trace. I'm looking for, obviously, a minimum on this one. If you didn't know, you could look at the picture and find that and get that it's a minimum and negative 3, 0. I could also, while I'm there, also look at my transformations, and I could use this either the vertex form, the min max, or the graph, any of those to find my transformations. And I'm going to find I have no flips, no stretches, no shrinks. I move, I'm just going to have left 3. Because my vertex is negative 3, that means I move to the left negative 3. And I can see that easily from the graph. No, I can't talk. The rest of these, things you've done before. So factored form, I'm going to be multiplying out. So x times 10. I'm going to get things like x squared for x times negative 10 is negative 10x. Negative 4 times x is negative 4x. Negative 4 times negative 10 is positive 40. So I'm going to get x squared minus 14x plus 40 as my standard form. That's going to go right there. And I'm going to start with y equals. Y equals x squared minus 14x plus 40. So you know how to do that. It's a similar process when you're doing your vertex form. You got to remember, order of operations always applies. Order of operations always applies. So we're going to multiply that out. So that's going to be x minus 7 times x minus 7 Let me get my brain to work with my hand. Plus 3. And I'm going to multiply this out before I add the 3. Multiplying before adding. If they give me the roots or solutions, just like I use the factored form to find my roots or solutions, I'm going to go the other way with these. So I'm going to change the sign. It's going to be x, that's a positive 4, so it's going to be x minus 4, parentheses. X, that's a positive 15, is going to be x minus 15. And I need to make sure I don't forget my y equals out front. Once I do that, I can multiply out to get my standard form. The one that tends to be a little bit tricky is going from my vertex or my transformation into vertex form. Remember, vertex form is always y equals a times x minus h squared plus k. So, things I need to look for. I have a max in my vertex column. I have that it's flipped in my transformation. Both of those tell me that a is negative. So I've got y equals negative. There's no stretch or shrink mentioned over here, so I got a parentheses. X, now I got minus k, so that's the opposite sign of h, minus h. So I have the opposite sign of h. H is my x value, so negative 4, the opposite sign of that's going to be plus 4 squared. Then I got to look at k. K is my y value, and I keep the same sign, so plus 7. And that's vertex form. After you do that, you distribute that out. Remember, you're going to do x plus 4 times x plus 4, because exponents come before multiplication and before addition. So you're going to distribute negative x squared plus 8x plus 8 plus 7. You're going to multiply that negative times all that before you add the 7, because order of operations tells me I multiply before I add. And that'll help you get your standard form. Alright, nearing the end. So on this, you're going to distribute one term to all the other terms. Okay? One piece at a time. I'm not going to leave all that on there because it's confusing. But 7r squared times 2r minus 4. So I'm going to do 7 times 2r, which gets me 14r cubed, because I'm going to multiply the numbers out front, 7 and 2. I'm going to add the exponents, so 2 and 1. So 7r squared times negative 4 is going to give me negative 28r squared. Then I'm going to go to my next term. Negative 6r times 2r. So negative 6 times 2 gives me negative 12. R and r gives me r squared. Negative 6r times negative 4. So negative 6 times negative 4 gives me positive 24r. I'm going to go to my next term. And I've told some of my guys they can mark those out after you use them to make sure you don't use them again. Negative 6 times 2. So negative 6 times 2 is negative 12r, because I can't forget it. Negative 6 times negative 4 gives me positive 24. So that's a lot of stuff all combined. I've mentioned before underlining like terms. Got a pen or a highlighter, you can use those to help you out. Make sure you get all the same things, the same color, or just grouped together. Okay, so 14r cubed, there's nothing to change yet, so I have 14r cubed. Negative 28r squared and negative 12r squared, so negative 28 and negative 12 gives me negative 40r squared. Then I do 24 and negative 12r is going to give me positive 12r plus 24. That's my final answer. There's no y equals or anything because we have an expression, not an equation. The rest of those are really pretty straightforward. I'm going to go through them super quick just so that I have them done. But basically the same thing, multiplying those out. The biggest mistakes people make on these, they don't pay attention what the sign is. If you notice, this one is subtracting, not multiplying. This one down here is adding, not multiplying. There's some tricky things with that. I'm going to go through them super quick, trying to get as much as I can on that, just for time's sake. So I'm going to zip through these real quick. So I get 12x squared plus 9x. Then I get negative 16x and negative 12. You can also line them up like that. Gives you like a tally bar. So 12x squared negative 7x minus 12. It's going to be your final answer on that one. This one we're subtracting. Easiest thing to do when you're subtracting is to distribute that negative. So that becomes a plus 3 plus negative 3x squared minus 7x minus 3. So I go 6x cubed. I'm looking for another x cubed. There isn't one, so I have 6x cubed. Cross it off. Negative 4x squared. Looking for another x squared is negative 3. So I've got negative 4 and negative 3 is negative 7x squared. Cross those off. I've used them. X, looking for another x, is negative 7x. So x and negative 7x gives me negative 6x. Cross those off. I've used them. Negative 9 and negative 3 gives me negative 12. There's my final answer. Get down here to my last one. This one's a little tricky because order of operations always applies. So I've got to pay attention that there's a 3 out here first that's got to be distributed to all those terms. So I got 6x cubed minus 12x squared minus 6x plus 21 in parentheses plus 4x cubed plus 3x minus 19. And again, collecting those like terms. So x cubed and x cubed. X squared, I don't have any other x squareds. X and x. Constant and constant. You can color code it that way if you need to. Help you out a little bit. Or you just underline, make sure you got them as you're going or cross them out as you're going. So my x cubes, I'm going to have 10x cubed. Cross them off. I'm done with them. My x squared, negative 12x squared, because there wasn't any other x squared terms. Cross it out, I'm done. Negative 6 and positive 3 gives me negative 3x. Cross them out, I'm done with them. Negative 20 or positive 21 and negative 19 gives me positive 2. Cross those out, I'm done with them. Double check and make sure I used all my terms. That's my final answer. Most common mistakes on these is not paying attention to what sign there. That's probably number one mistake, is not paying attention to the sign. Add, subtract, or whether they're touching and it means multiply. Next most common mistake is your signs. Paying attention to whether it's positive or negative and treating it appropriately. Last is just not paying attention. Whether you're trying to multiply exponents when you should be leaving them alone, whether it's trying when you should be multiplying or adding exponents and you're doing something else like trying to multiply them. Don't do those things. Pay attention to the little things so you don't make simple mistakes. So we can look at that equation. Sorry for the bell there. We can look at that equation. It's going to model it. And then we're going to be able to pull some information out of this. The tricky one on this one is don't miss that question right there. It's actually the first question. What is the height of his bat when he hits the ball? It's real easy to miss that one just because it's not separated out like these guys are. But what is the height of his bat when he hits the ball? So anytime we're talking about starting value, we're talking about our y-intercept. That's where it crosses the y-axis. If you remember from our table, the y-intercept is always the c value of our equation. So to answer that one, we don't even have to graph it. We can look at the equation right there and know that the height of his bat was 5 feet. If we don't remember that, we can graph it. I'm going to go ahead and do that real quick. So I'm going over to my calculator. And if I graph it on a standard window, it looks like this. And I can't see that. So what I'm going to do is I'm going to change my window. Now, you may have learned zoom and zoom out. And you can do that. The only challenge with that is that zooming out, sometimes you get really squished graphs. And it's hard to tell exactly where everything is. But if you're really careful, your calculator will still find it for you as long as you can see it. Your calculator will not find anything you can't see. I'm going to set my window. So I don't need negative values because we never have negative time. Never have negative time. So we don't need that. X max, I could see my other X value where it crossed there. If I look at my graph, I can see where it hits the ground here. That's where it hits the ground. So I can see that. I don't have to change it. I can if I want to, but I don't have to. Other things, my Y values are going to change up and down. So hopefully Ferdinand's baseball is never going to be underground. If there's something else going wrong, if it is. So we can actually get rid of these negative values down here. It's not going to be underground, but we need to go way up here somewhere because we can't see that vertex. We need to be able to see that vertex. It's important. I'm going to go back to my window. Y min is how far down I could see. It's also the arch nemesis of the X-Men. 0. Because I don't need to see underground. That was a bad joke, sorry. I don't need to see underground. Y max. I can see to 10, and 10 is not far enough. I'm thinking I'm hitting a baseball. So let's try them out here. Let's try 50 and see if 50 feet was high enough. And just so that I'm not counting by ones and it's crammed, let's say 10. We'll count by. That's the Y scale is what I'm counting by. So I graph it, and I can almost see that. So I'm going to pick a number bigger than 50 so I can see my vertex. It can be close to it, or it can be not super close to it. I'm going to go ahead, and most of you will probably pick 100. So I'm going to hit graph. And I messed up by changing. Sorry, I changed the wrong one there. It moved one more when I didn't expect it to. So I'm going to change that to 100 and leave my Y scale back on 10 where it's supposed to be. And I'm going to graph that. Now you see, I can see my vertex. I can see my 0. I'm good on that. If I needed to find my y-intercept, I can go to my table, and I'm looking for where x equals 0. So that's 5 feet. If I can remember the c value of the equation, that's a lot easier, but if not, I can go to my table. My next question on there is, at what time did he hit the ball? Anytime we do starting value in real life, starting time is always 0. Always. I don't have negative time. Starting value, he started at 0 seconds. So when did he hit the ball? What time did he hit the ball? 0 seconds. If I go back to that, it is 0 seconds. 0 seconds. What time did his ball reach the maximum height? Here's the tricky one, is it's what time does it reach the maximum height? Most of you are going to see that maximum height and go, oh, it's a vertex. I'm going to find that y value. I'm going to see how tall it got. But on this one, it doesn't want how tall it got. It might. If it asks what's its maximum height, you're going to find that maximum height and you're going to plug it in there. But this one's tricky because it wants the time. It also wants it as an ordered pair and explain what it means. So let's go back and do that. So let's find vertex. Pull up my calculator here. Go back to my graph. There's my vertex. So I'm going to go math on a graph. I'm going to second calculate. I'm going to find a maximum. I'm going to hit second trace. I'm finding a maximum. I'm going to move my spider until I can see it. Got a long climb on mine. Itsy bitsy spider, climb the parabola. Here we go. There we can see it. I'm trying to make it to the left of my vertex. So left bound means just to the left of the point I'm looking for. Keep on climbing here. Hit enter. So I'm to the left of it finally. Right bound, I need to be to the right of it. Say enter. The guess is a dumb feature here, but it does give me a chance to check my arrows and make sure they're pointing at each other, make sure I had left and right correct. And I do, so I hit enter. And that's my vertex as an ordered pair. Now, I always tell my guys, unless it tells you otherwise, to round to 3 decimal places. So, on this one, my vertex written as an ordered pair is going to be parentheses. I'm going to go 3 digits here, so 1, 2, 3. I'm going to cut that off there. I'm going to look at that 2, and it tells me that that stays a 1. So I've got 1.781, comma. Look at the first 3 digits of the other one, and I look at that 6. So that tells me that 5 is going to become a 6. So I got 766. That's my ordered pair. So that's part of it. So I'm going to copy that real quick and go back to my review. So there's my ordered pair. Right. I'm going to shrink that a little bit. And there we go. What time does the ball reach the maximum height? Well, time is always my x values. So it's 1.781 seconds after he hits it, when it reaches the maximum height. What does it mean? It means after 1.781 seconds, it was our height over here, which is the y value, 55.766 feet in the air. And that's all it means when it wants to know what it means in real life. Well, it's after that time, it was that far up in the air. Pretty simple. Don't let that mess you up. So assuming the catcher messes up and misses it, when's the ball hit the ground? So if we go back to our graph, we're looking for ground here. Ground is our x-axis. So we're going to be finding that 0. So we're going to math on a graph again, second trace. We're looking for a 0. That's option 2. We need to be left bound on this one. So we're left bound to this point. So that's to the left of that point. If I'm looking to the left of that point, I see my graph is above the axis. So up there somewhere, enter is good. Right bound. So that means right of that point. So to the right of that point, my graph is somewhere down here. So I'm looking for these y values to turn negative. So I'm going to keep hitting the right button until I see those y values turn negative. There we go, negative. I hit enter and double check my arrows real quick. They're pointing at each other. I'm good. I hit enter. And I know that doesn't look like 0, but that is. So at 3.648 seconds. 3.648 seconds is when 3.648 seconds is when it hit. Right? Double checking that. Yes, 648 seconds. On what interval is the ball in the air? So, this is always going to look the same. It starts in real life at 0. X values are, so you got 0 is less than or equal to, X is less than or equal to that second 0 when it hits the ground. So we've got starting time, X values, ending time. 3.648 seconds. That's the interval it's in the air. What's a reasonable domain for the problem is the same thing. 0 is less than equal to, X is less than or equal to 3.648. The only time those are different is if the interval it was in the air, if there was a delay before it was hit. For example, the rocket problem you had on your last test, it was about 25 seconds before the rocket made it out from the underground bunker. So that would be 25 to its second X value where it hits the ground. This one, it stays that way because 0 is when I hit the ball. Alright? That's the whole review. That's the whole thing going through. I hope that's helpful, and good luck on your test.